All right. So, great job on making the table. That was step one. Okay, and using their walking rate. What's another term for these walking rates? What else could you call those?
Either a rate or a constant.
Okay, a constant. What else could you call them? What else? A rate, a unit rate, yeah. Any other? Could it be a proportion? Like it's the same proportion over and over and over? So there's lots of ways that you can describe their walking rates. So looking at the walking rates, obviously you have three graphs, right? 3-line graphs. What do you notice about the 3-line graphs? Yeah.
Wait, we were supposed to make like 3 of them. We're supposed to all graph one the same graph, right?
Yeah.
Just making sure.
But what do you notice about? What do you notice about them?
They're all different colors.
Okay, so they're all different. What makes them different?
Speed.
Speed. Okay. And what do you notice about the speed?
It gets higher and higher as it goes along.
Well, say that again.
It gets faster and faster as it goes along.
So we have ones that are fast and we have ones that are slow. What kind of lines do they make? Straight lines. Why are they straight?
Because it's the same rate.
Because it's the same rate and they're linear. Okay. So I'm going to ask one more question. I want all you guys to put your pencils down now. Just Eli. Jayla. So we have 3 straight lines. Okay? And each line is different because of the speed. So my question is, we notice that each line represents a speed, a unit rate, a constant. What kind of line does this make for a rate versus this versus that? What speed is this? Fast. So when it's fast, what do we know about the kind of line it makes? Steeper, right? Right? This would be like a black diamond, right? This would be like your intermediate blue, and this would be your green, right? If you're a skier or a snowboarder. The steepness of the line matters based upon your unit rate. That's a really big idea, like super big idea that you need to remember. That if you're plotting walking rates and they're all like the same, if someone walks faster, what kind of line are they going to have? A steeper line. They're going to have a steeper line because they're walking faster. It doesn't mean that they walk farther. It means they don't take as much time. They walk just as far in less time. And that's what makes it steeper. We have over here is Peyton. Okay, and then over there is Otis. But right before that, hold on. Is it Otis, right? Yeah. Yesterday, I think I did talk to you guys. I think it was this group. No, I don't think it was this group. But you guys did a really good job yesterday. But I want you to remember that I like the groups. I'm going to keep them. I just want us to be more focused. And like I said, in here you did such a good job I didn't have to make a comment. But I do feel that every class does need to improve a little bit about their focus. The reason why I want you in groups is so you could do what? Why are groups important to me right now? Hold each other accountable. What else can you do? Converse. What? Help each other, support each other. What else can you do? You can communicate. Hopefully about math. Eli, I just wanted to add that on there, that's all. To make sure you didn't say, but Miss McFarland, you said we could communicate.
Yeah.
What else? Why else might groups be beneficial? Besides those ways. Any others? Can you learn different ways to solve the same kind of problem? Okay. That'd be one more that I'd want to add in there. Is that having 3 ideas plus your own is going to allow you to see like, oh, I didn't realize you could do it that way. Because there's lots of ways to do math. They're not just one way. Today we're looking at predicting and determining whether a relationship is linear. Kind of continuing that same thread, just a little bit different. More kind of predictions. And remember, as the steeper the line gets, the higher the unit rate. The rate is higher. So let's go Otis, this side over there, this side over here with Peyton. Otis, you should be guiding and talking about how you solve these problems. And the rest of you need to be asking him questions. Thank you for bringing your papers. You don't have yours? Or you do have yours?
Yeah, I do.
Okay. Try to get that out. And Peyton, come on, get up there and talk about how you did it. Okay, no, go and tell him.
I disagree with this one right here. I say it's -2 plus -2.
So wait, we have a big question mark. Before we go down to 16, let's talk about 15. So someone who has an idea, start communicating.
I think we were supposed to write how it is going time, so how it first starts at then it went to that 1, 2, 3, 4, 5.
That's what I had for number 15. Had it memorized.
And then I thought B, we had to draw the graph.
Okay. How you looking? Do you have yours?
I left mine at home.
Okay, so go work on it. This is time that you
No,
can...
I did it. I just
okay.
Yeah.
So just bring it to me tomorrow.
I agree with everything besides this, but I also did draw the graph.
Ooh, that's good. Talk to him about it, though. It's good. Yep, you do. Perfect.
Were we supposed to make a graph for number 15?
It says look. So like you can say in words.
Yes, you could. But you also could draw a graph too. That's another representation. See, this is why we work in groups. 2 ways. One's not more right than the other. But you can say one. This would be a faster rate because, and this would be a slower rate. But you also could show it in a graph.
Okay. Thank you.
Hey, did you do yesterday's?
Yeah, I did.
Oh, I did mine as well.
Here's mine from yesterday's.
You did?
I don't like it.
Peacock, did you get your? Hey, Peacock, did you get 1 and 2 done?
Oh yeah, that's the reason.
Schmitty, did you get 1 and 2 done? You got that? No, yesterday's. Remember, you forgot. Okay. Remember, you can still do that and show me, and you'll get 6 out of 6 for the week.
I just forgot about it.
Taya, did you get 1 and 2 done?
Yeah.
From the day before? You did. Okay. Any other comments for her? So, Braden and Justin both said, well, I didn't. One drew a graph. Justin wrote words.
So did I.
And so did you. So you didn't have to show it, but it says,
Boom.
what do the walking rates look like? So you could visually show, or you could verbally write it down.
Well, I tried doing that. It didn't make no sense whatsoever.
So you went to drawing it. Okay. All right. And did you remember you got 1 and 2 too?
Yeah.
Okay. All right.
Sorry.
Hey, Eli, did you get 1 and 2 done?
Oh yeah, I do have it.
Okay, hold on.
This side and then.
Okay. Eva, you got 1 and 2 done? Okay. All right. Did you get 1 and 2 done, or you just did yesterday's?
What do you mean?
1 and 2 from the day before.
What?
1 and 2 from yesterday. Remember? Everyone forgot that I. Well, you and I.
Yeah, I did. Yesterday's and
Okay.
last night.
Okay. That's what I was asking.
Mondays and last night.
All right. So, not much confusion here. A lot of solid understanding, which is great. So, going to move ahead to 1.2. So, please get out 1.2. So, still talking about the before BC, right? The rail jam that we were talking about doing, but now I guess my wife's made other plans possibly, and we might not be able to do it, which I'm really disappointed about. What? So I want to give you some ideas on the time. So the course is 100 meters, and what we discovered yesterday is that Grace takes 200 seconds to do the course. So I'm trying to find her meter per second rate. That would tell me how many laps she should be able to do in that amount of time. Her walking rate is 100 meters, and she can do it in 200 seconds. So I go 100 divided by 200, and I get 0.5 meters per second. That is her constant. Her constant proportionality is 0.5 meters per second. Now, it sounds slow, and it kind of is, because you got to take your skis off. You got to put them together. You got to hike back up. You got ski boots on and snow. So it's not like super fast.
How many rails
Okay.
are in the park?
It's 3.
Oh, so
For her line, it's 3.
So there's 3 rails.
3 rails in the 100 meters.
Have you guys ever been to the?
Well, in 50.
It's kind of off topic.
Yeah.
It's
Yeah. So here, I can come over here and I can plot and make this graph or table like you did, and I could say, well, sugar.
This is all girls basketball players for their away game today at Fremont. Thank you.
Go, Addie. Go, Addie. Go, 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 Addie. Go, Addie. Hey, don't break any backboards, okay? If you dunk, don't hang on the rim.
impossible.
Trying to do a slam dunk, and he got his
Finger caught. Oh yeah, yeah.
It was just really cringy one where like,
So here at 0 time, Grace has gone 0 distance. Now I could make this a very sequential table. Make sure you're following along, but it doesn't have to be. So I could say, well, where's Grace in 10 seconds? And I'm going to write time, and this is in seconds, and I'm going to put M up here for distance. And then I could say, well, what about at 220 meters, or 800 meters, or let's say 1,020 meters? It's in order, ascending order from least to greatest, or descending order, from least to greatest. But it doesn't have to be sequential, like 0, 1, 2, 3. Not all tables are that way. But I do know that her rate is 0.5. So my thinking is her distance is going to equal her rate times her time. Well, I don't know her distance. I don't know the time, but I do know her rate. So I'm going to plug that in. And now I have my equation that will help me figure out how far she's gone based on how much time. So now that you know that, and I have these values over here, I can use that equation and put the time in, and then I get the distance. So you know that if I put time in, I get distance. So is distance dependent on time, or is time dependent upon distance? Which one is dependent on the other? Talk to your tables. Why? Why is distance dependent on time?
You have your rate, and it's time tells you how far you've traveled.
So based on how much time, that's how I figure it out.
The distance depends on the time.
So Justin was saying, well, my distance is always going to depend upon how long she's doing the course. So that is why time is over here, and I want you to write, this is the independent variable. And this is the dependent variable. So, and that's typically how it works out. Your independent variable is usually the first one in your table, and the dependent variable is usually the next. So, here, she's gone 5 meters in 10 seconds. Here she's gone 110 meters in 220 seconds. In 800 seconds, she's gone 400. And all I'm doing is taking those numbers and multiplying it by the rate. And it's half every time. And then here she's gone 510 meters. Now that I know how long she's gone, I know that how many rails are in the sequence? 3. I can figure out how many laps she's done. Because how long is a lap? 200 seconds or 100 meters. It's 50 meters down and 50 meters up. So I can figure out how many rails she's going to do that way like we did yesterday. So when I go here, I have my y-axis and my x. Talk to your partner. How do I label this? Which variable goes where? Which variable's on the y? Which variable's on the x? Go.
The independent variable is on the y-axis.
What do you think? Dependent. So, Eli was saying dependent is the y. This should be my distance. Whoops. Distance, and that would be in meters. This is my, dependent. Oh my goodness. And this is my independent. And this is going to be time, which is in seconds. Now I could go ahead and plot that, but you guys have already got that skill super solid. So the question is, I have this representation here for my equation where d equals distance and t equals time. What would happen to the graph if Grace increased her walking rate? So let's just say this is her graph to start. And she increases her walking rate by 0.5. So now how fast is she walking?
10 meters per second.
I'm increasing her walking rate. What's her walking rate now? 0.5 meters per second. I'm going to increase it by 0.5. So now she's walking 1 meter per second. What's going to happen to her graph if she increases her walking rate? Talk to your. So Connor's saying it's going to get steeper. And specifically, I know that it's going to be 1 meter per second. So it's going to go right up the middle. For every 1 second, 1 meter, right? And so her walking rate is going to get steeper. It's kind of like what we talked about in the warm-up. Right? You have those walking rates. The faster the rate, the steeper the graph. So today you're going to be working with the walking rates yesterday with Gilberto No.
Naruto, Yoshi, Annie, Lenny, Annie.
Something like that. Those three. You just did them in the warm-up. So, it's on page 10. You guys we have already answered this question here, so you do not need to answer this. You're going to start on A3.
And then we go A3,
Yay.
So when you guys talk, just talk loud enough.
We get to be on a YouTube video. Yeah.
Your name's going.
Yep. Making dollar bills soon. Making dollar bills soon. Alright. 10. 8. Okay, write an
Hey,
equation.
that lab sheet 1.2, you want to put that in your learning.
Okay. Write an equation that gives the relationship between the time t and the distance d walked for each student. How is the walking rate represented in the equations?
Come on, guys. Less talk, more focus.
Okay, well, wouldn't it be d equals
Can't.
d?
No.
D equals
Next one you're going to be on time.
a.
Wait,
Write an
for
equation.
each student, so we're going to do Alana first. Or, I don't know.
Elena, I think.
Yeah, so D equals 1 second times the time.
Times the rate.
So
Wait,
that's,
the rate
We'll start on A3, guys.
times the time.
that's
T.
Alana, and then
D equals 2 times.
no. Yeah,
Yeah, we
2.
should say it to ourselves because if the person listens and just get all the answers. Just answers.
So let them have it.
Alright. Alright, and then D equals 2.5 times T. Alright,
And then that's who's that?
A4.
That's Leanne or whatever, or Lean or whatever.
A leaner.
I don't know.
Leanne. Gilberto.
Gil.
I thought it was just Gilbert. Elena. Are you working ahead of us? No.
What does it matter? 4. How can you predict that the graph will be a straight line from the patterns in the table and the equation? Do we have to use the paper we used for a warm-up this morning?
No.
Wait.
Alright, A4.
How can you predict that the graph?
Will be a straight line from the patterns in the table and the equation. Explain. Well, we already did it.
A straight line. How it will be a straight line?
The rate is going up by 1 second each time.
It's because the line or the rate. Well, it's because
The rate's going up by
lines are
1
going to be
second.
straight because the lines are going to be linear. How I know.
Yep. You did it on the lab sheet.
What would you say?
You should have.
Lines
Wait, I don't see your equations.
A.
Wait, I wrote it down on
No, that's fine, but I want to see your equations to make sure.
maybe.
Equation.
Is it that timer that Mr. Getz puts on there?
E3.
Yeah. Those things that he put up in there don't really help that much.
No, it's just right.
Yeah, in Mr. Getz's room, they don't really help that much.
Time.
Yeah, you can't hear anything in Mr. Getz's room anymore.
Yeah, Mr. Getz's. Straight is because
write down the equation.
Okay.
T
No,
times.
okay, A5. Alright, so are any of these proportional relationships? If so, what is the constant of proportionality?
Yeah, they're proportional relationships because you know that the
Yes.
constant of proportionality
That's
is basically almost the same as the unit rate.
So now, that's the
Because the constant of proportionality is like Mr. McFarland said with the whatchamacallit. I forgot what they're called.
So, Alana is what be Alana.
Equations. How the equations have the unit rate in them. See? With the unit rate.
Well, you would just write
Constant
T of
proportionality
you would substitute.
is the exact same as the unit rate. Kind of. I guess. Sure.
And that would be her.
If so, what is the constant of proportionality? What? But they're asking what
Yes.
is the constant of proportionality?
The unit rate.
Yeah.
Yeah, the constant of proportionality is the unit rate.
Is the unit rate.
Yeah.
Yeah.
Just another word for it.
Yes, there are. There's yes, there is. There's.
So here in A3, you wrote down the standard. What they're asking you is write an equation that gives a relationship
The unit
for each
that's.
student.
I don't know. I'm just thinking here.
Here is a proportional relation.
What would be
Ship.
Alana's?
Proportional relationship.
What would be Alana's?
Stop! What are you doing?
Equation.
Stop, just leave it.
Oh, I can't see me anymore.
Kind of what I was showing
Yes,
you.
there is a
Very
proportional
similar,
relationship.
right?
And
Very similar. It's like the rate is something that's constant, so it stays. But then as time changes, so does your distance. You know.
Ship.
So
Ship
what was Grace's
is.
walking rate? I mean,
He's confused on the first one.
Yeah. We literally wrote the answer.
What's her
It's
equation?
the equations.
It's like 1 times.
And the proportional relationship
That's not her
is
equation. That's the
is the-
standard. What was her equation?
wait.
Alright, so
Okay. So
B.
That's
If time t increases by 1 second,
B1.
how much does
Wait,
the distance d change?
Wait, calm
How
down.
is the change?
B?
How is the change
Now that
represented
is
in a table?
that is her walk. That is her quick line.
B1.
I'm reading it to
If
this
the
thing.
time, the time increases by 1 second, how much does the distance change? How is the change represented in a? How is the change represented in a table in a graph? So they're asking us 3 questions here. They're asking us how much does the distance change,
That's her.
or by
No,
how
I'm
much?
supposed to.
How
This
much?
is right in a mathematical number, like.
Her.
Yeah, I know. We can write all of that using that mathematical rubric, or yeah, whatever.
What's
But it's asking us 3 questions. How much does the distance change? How is this change represented in a table and in a graph?
Just by 1 more.
Okay. So
whatever her time is?
if it increases by 1 second, the distance of
That's
how much people walk,
So what you have is you have the standard.
much
Oh, that is true. But that's
How much
that's
people
not
walk.
the equation.
the distance of how much the people walk
And this,
will
this is the
not
shows.
not change.
Okay, I kind of
Range by much period. Now, for example, you want to make a graph?
No, they're gonna. That's why.
Wait, but for example,
you can explain it.
So you can put.
For example, by just adding 1 second, is it going to change the distance by much?
What does change?
Right? Because those people only walk. One person only walks 1 meter. Like, it's not going to change it dramatically. Like,
Does that make sense?
by walking 1 more second. Like Gilberto, by walking 1 more second, he's going to just get 2 more meters in. That's it. So, for example, 1 second.
Wait, 1 second. It's just in a graph.
It's
asking us how is this change represented in a table and in a graph. If the time t increases by 1 second, how much does the distance d change? How is this change represented in a table and a graph?
Yep.
Well, let's just answer this, and then we can write how it's represented in a graph and in a table.
What?
Well, I'm just saying, we can put an example for that. 1 second.
I'm confused. We're confused with C.
I think his might be 1 because he has a rate for it. I already said that like 5 times. Have you not
She's
heard me?
good. So that's 1. He has a rate. Is there a rate over here?
I don't know what this means.
We'll look at it.
I'm looking.
It doesn't look like there's rate in.
I don't think there's a rate in these ones.
Or this one, because it's like 1 to 2, and then 2 to 9, and then 11.
Yeah, I don't think there's a rate in that one.
And then this one it goes up 1. Here goes up 2.
This one goes up 4, and this one goes up 5. That doesn't make sense.
Oh, so wait, this one is.
You think so?
Yeah.
Why?
Because every time you do it, like here goes up 1 meter per second.
This one goes up 2, this one goes up 3, this one goes up 4, this one goes up 5.
Yeah. So,
But what would the rate be for that?
well, add 1 over times.
Well, no, because over here it's like at 2 seconds. The idea is, if you think you're right, the idea is make an equation and see if you are.
Wait, the rate would be times 2 plus 1. No,
Times 2 plus 1. Hold on, wait.
Oh, that's not bad.
2 times 2, it wouldn't be 3.
All right, guys, please go ahead. Put away your. Did you get to see?
How would the distance be? How would you show in a graph how the distance is go up?
Yeah.
Then I thought if it's going up, then that means that the person going up.
Yeah.
I said you theory.
What do we do right now?
All right. Yeah. No. Put. Hey, Justin, what did I have you guys write in your warm up?
You have us write table and graph.
Table and graph. All right. Okay. Next, exit ticket and homework. So I'll hand out the graph paper as you guys are finishing up, because you're going to need the graph paper for tonight. It is 3 A through E. It's not all of 3, just A through E. That's it. It's on page 16. We were looking at predicting if something was going to be linear. The group in the back got to see. That's a really good question. You guys were doing a really good job at working through that. It says, explain if the graph is linear. Obviously, I don't have the graph, but I do show you the table that would make the graph. So would it be linear?
Yes.
Because it's really easy putting a graph up and be like, yeah, straight line. It's a little bit harder putting a table up and being like, oh, is that linear? How do you know? So that is A. And then B is write an equation for the distance D the cyclist will travel after T hours. So again, helping us understand how to write an equation that shows a linear relationship. Oops, sorry, Justin. Just for your homework. Shouldn't take you guys more than like 10 minutes. Yeah. 3A through E. That's for your homework, Schmitty. Hey, some of you forgot to get caught up. Hey guys, some of you forgot to get caught up on 1 and 2. They're both really good questions, and they don't take very long. So, good independent practice would be to just get those done and just remember to show me. I want to give you credit for that. So we have 1 minute. Braden, is it linear?
Yeah.
How do you know?
Because the unit rate.
Okay, so Braden says because of the unit rate. What is the unit rate?
6.5.
So we're going up by 6.5 every single time. Okay. And then what would the equation look like for the cyclist? Tatiana.
It would be E equals 6.5 times E.
Bingo. That would be your equation. That way, Austin, I can put whatever I want in for my independent variable, which is my time. If I decide to go and bike for 6 hours, which would be like, wow, that's impressive.
I did a mile.
You biked a mile?
No, I'm kidding. I mean,
I hope so.
I ride at the speed limit, but a mile.
That allows me to figure out my distance. All right, guys. We'll see you guys later. Have a good night.